All right, folks. Thanks for joining us, and yeah, we're excited to dig into a webinar that well, I was going to say this morning or this afternoon, depending on where in the world you are. Um Ricky and I will have you covered on multiple time zones here. But yeah, we're going to talk about batch purchase streaming with StreamCap, um, and yeah, we'll kind of dig right in here. Paul Dudley, I'm the one of the co-founders and CEO of StreamCap, and I'm joined by Ricky Thomas.
Yeah, hi. I'm CTO and look after product.
Right. So yeah, I think perhaps folks who are joining this have seen that streaming is gaining momentum. We're seeing more use cases, more adoption. Thought it'd be a good time to help kind of dig into some of the differences between batch and streaming, and then some of the opportunities that have opened up recently. I think to help folks get into streaming to power more real time use cases that have that have gotten a lot more accessible than they were in the past, and some of the trends we're seeing there. So yeah, what we'll do is we'll dig into kind of overview of some of the differences between batch and streaming, some of the use cases for both, and I think critically how we're seeing the landscape changing, how folks are adopting streaming, how it fits into their current stacks, and we'll look at a real life example from SpotOn, which is one of our customers. So yeah, excited to dig into it. Before we do that, though, we thought we'd start off with a question for the audience. So if you're on LinkedIn or YouTube or here on the webinar, just jump into the comments and let us know. Are you on a fully batch infrastructure, and what are you using for ETL? Is it a tool like Fivetran or Airbyte, or are you building something yourself with Airflow or Spark? And yeah, if you're doing streaming, what platforms you're on there, or you own a combo. So we'd love to hear from you all, and we'll give you some time to do that. But I think at the same time we can come back to that answers to that question after we've dug into this first section. So Ricky, do you want to take it away?
Yep, thanks. So yeah, let's start with some differences between batch and stream processing. I know most of you are probably have some familiarity with it, in particular with batch, because that's what we handle mostly today. But we're just going to step through sort of 6 or 7 key differences in batch, and then how we handle it in streaming as well. So fundamentally, batch, as it sounds like, is handling a quantity or a batch of records at a time. So usually on an interval. That interval can be 10 minutes, an hour, and so on. But an example might be end of month financial accounts or payroll, in effect, where you will gather up all the data in different departments, hours worked, and so on, and then finalize your accounts. And so that would make perfect sense for a batch processing need. And then on streaming side, typically this could be something like Google Analytics offers a tab in their system where they look at how many visitors are on the website right now. So how many are on it right now, how many are checking out, and so on. So this is typically what's been thought of as a kind of batch versus streaming process and use case. So just have a look at the next one, and we can have a look at complexity. So batch processing has been actually very simple to use, especially today. We've been doing batch for 20 plus years. While the tools have generally moved away from desktop to web-based, the principles are kind of the same, but more web-based, cheaper, and easy to use. And you'll find that in general, you don't need to be that particularly technically savvy to be able to connect two systems together, for example, and move this data. Streaming, on the other hand, has typically been left to the enterprise. We're looking at streaming real-time data in. We have to think about distributed systems in case one goes down, and delivery guarantees and so on, just to make sure it gets delivered. And typically, you do need to be technical. You may be a data engineer, you may be a developer, but that's what it's going to take to handle streaming generally. And when we think about data consistency and completeness, so with batch, it's quite easy to do consistency and completeness for both. We're going to grab a chunk of data and put it in the destination. We will commit that transaction in the destination probably as it's kind of all been merged into the data. And therefore, we've moved that data from source to destination. It's both consistent and can be complete. So if it's a transactional set of data, I can ensure that my 5 or 50 tables data are in alignment with each other, ready for analysis. With streaming, of course, this is much harder as you're streaming data in. You're streaming from usually often multiple data sources, multiple tables, and you're spreading that across multiple systems. So we do need to think about delivery guarantees, making sure that data can't be tampered with on its way in. We need to think about watermarking sometimes, which will be like where did we read from and the last time and next, offsetting, and then of course windowing is also useful potentially in completeness with streaming data. And when we think about analysis, typically we do our analysis in batch, and the easiest scenario there is BI dashboards. This is very typical, of course, and there are metrics such as sales, which can be updated, say, every hour or every half an hour. And there's definitely certain analysis and metrics such as customer lifetime value where you wouldn't want it in real time. And it's quite a heavy calculation if you're going over multiple years of data, multiple joins and calculations and so on. And so typically that's for batch. It's very efficient. It has worked until now. And then streaming, again, as I mentioned earlier, we were typically looking at small windows of time. So again, visitors on the website and so on. Now, generally people just might turn around and go, well, I haven't got a real-time use case and so on. But the way things are moving with real-time pipelines and real-time data warehousing and so on, that actually you can look at your sales, up to the minute, and any other data that might be interesting, such as conversion and so on. Okay, and with error recognition and resolution. So typically, if the batch process fails, you've got time to look into it, probably before someone needs it. But you won't know until the whole lot has failed. So if you're on an hourly batch, you won't know until an hour later or daily that it's going to, it's broken and it needs fixing. This is quite problematic sometimes. Quite often people run their batch processes at night and therefore come in the morning and it's broken. On the flip side, streaming will allow you to identify problems in real time, allow for a faster resolution also because you can work on it there and then. Of course, it's a slightly double-edged sword. The faster you move that data, the more it will get used downstream by the business. And then, of course, they'll still be complaining that it's broken, even though they were used to hourly updates before, and now they're getting, every minute, for example. And obviously, we've kind of mentioned it anyway, but with the latency, hours and days is pretty typical, especially when we think about pipelines and just moving that data downstream. Some tools are now some of the batch ETL tools are starting to offer 5 minutes, usually for increased cost. You can get below 5 minutes, but in all honesty, at that point, it starts becoming pretty inefficient. There's all sorts of other issues that can happen also. And whereas stream processing, you're really thinking sub-second, 1 to 2 seconds maximum for the full end-to-end pipeline. And that can include real-time transformations also. So a kind of ETLT approach, basically. So I've kind of touched upon it now. Touched upon it just now. So the batch processing world, this is the typical billing, payroll, financial reporting, your nightly backups. APIs are usually ran on a snapshot. You pull the API every hour and so on. Also, even things like recommendation systems for e-commerce or personalization. They will tell you they're real time, but actually they did the analysis the day before or the night before, or at least several hours before, where they then grouped and segmented them. So a lot of data science work is done on batch also. Clearly, that's starting to shift with like the whole Gen AI sort of situation we're in now. And so where stream processing used to be constantly labeled as what are the use cases? It's IoT, it's fraud prevention, maybe web events, this sort of thing. That seems to be massively shifting, where you're now seeing all customer-facing apps. They are all beneficial to be updated in near real time. Personalization is happening, even including for one of our customers, within 2 seconds of an end-to-end pipeline. That allows for huge benefits in terms of increased selling. Logistics, obviously the likes of Uber and Deliveroo, but we're seeing it across other logistics companies also. There's no reason not to do dashboards faster. The business will like it. Data science needs it to start with a lot of these models now, and so on. So we're starting to see those use cases shift completely from I don't need real time to now being real time is becoming the kind of the standard, and especially for new companies, their outlook is to start in real time and then therefore provide better, faster data than the incumbents straight away when they're dealing with their customers, in effect.
Thanks, Ricky. Yeah, that's helpful. Hopefully, folks get a good sense of some of the differences there and some of where we see the use cases going. Right, like it's interesting if you're starting from scratch. I think there's a good case to be made to really build things event driven from the start. But I think a lot of businesses don't have that advantage, and so I think that brings us to the question of what is it that that's blocking you or giving you concerns about adopting streaming. We'd love to hear from you folks in the comments, whether it's cost, whether it's the complexity or skill gaps that you all have on your teams, whether it's just a general culture shift that would be required or anything else. We certainly see plenty of all of those as kind of concerns based on the the sort of the way that folks are looking at the landscape today, right? And I think to put a finer point on that, right? Like obviously batch processing is extremely well established and very widely used. There's a lot of tools out there. They're reliable and cost effective. And it I guess not only fits into traditional data workflows, it is the traditional data workflow. And I think for stream processing, there's a perception of it being complex and costly and resource intensive. I think a very classic data team response to, hey, we need data streaming, or we need real-time data is do you really need it, right? Because if you've got those cost and complexity and resource trade-offs, you have to push back on those things. And that comes out of having to manage the lower level infrastructure that's complex to manage. But I think our experience has been that things are really changing, and that it's getting much easier to adopt streaming. I think not to sell StreamCap too hard here, but we're a great example of you can actually adopt something and get streaming up and going in minutes. We'll talk about that a little bit more in a real life example. Costs are going down both for streaming services directly and some of the associated stuff, and that comes from growing industry support. So whether that's with some of the databases that you might be streaming to, like or data lakes like Snowflake and Databricks, or cloud services offering streaming and good support for it. Basically, like the tooling is becoming easier to use. The sort of broader ecosystem support is improving, as we'll see in an example here. And all that means that rather than this being sort of a binary and this huge hill you have to climb, the activation energy for getting into streaming is getting a lot lower. So yeah, with that, let's take a look at a practical example.
Yeah, so we'll take a look at a company called SpotOn. They kind of they do a bunch of things, but around point of sale was the use case here. So collecting point of sale data across the world for some of the largest companies. And if we take a look at what they were running, this would be a typical kind of batch pipeline for how the data is there. So let's start with the data was in a MySQL database, and data was being updated, not necessarily real time, but fairly real time. So data was flown into MySQL very quickly, and there's obviously processes upstream for that. And then we had a batch ETL tool with Fivetran reading from the transaction log, which actually is capable of real time, and then sending that into Snowflake using a Snowflake warehouse to do upserts, or the merged updates. And so those batches were going into Snowflake. And as you can see here, and these are our customers' slides, there was a delay of 20 minutes from end to end, and this was costing a lot, but that's not too slow, right? It seems pretty fast for a batch system. But it was costing Spot On a lot in terms of not Spot On, but the customers a lot, waiting for that delay to run actually payroll, where they wanted to run it faster at the end of the shifts for temporary workers and so on. And what we wanted to look at here was, okay, well, what can we do here without a massive culture shift, without swapping out lots of systems? And that's where we ended up working with Spot On here. So the first thing is that in pipelines really is the easiest step to then at least start moving to real time and further downstream to benefit the business, and lots of different places. In fact, usually developers, business, customer facing apps, sharing data, and so on. And the first part is, as I kind of hinted on the previous slide, is logical replication is already enabled 99% of the time in all these databases. And so you're able to then think, right, okay, I can read that data in real time. Why can't I deliver it in real time to a destination? Now, you can deliver real time data into, for example, Snowflake using the kind of batch process method, but it can get quite expensive to do so. And as you can imagine, the difference of doing 20 minutes or hourly updates. But overall, it is very easy to swap out the source to read real time. Swap out the engine in the middle to read the real time logs from the databases using change data capture. And so that's what we did. Streamcap was swapped out for Fivetran. But the other change we made, and this is where we talk about the industry moving to streaming, is that we utilize Snowpipe streaming. And Snowpipe was really for loading files into Snowflake. A JDBC type approach would be the traditional batch method. And then Snowflake released Snowpipe streaming, which can receive real-time data without any latency issues whatsoever, and have that data surfaced in sub 1 second. On top of that, they don't really charge for it. So it works out something like 15 credits, let's say $30, $45 per terabyte of data for the entire month. So the reality was we was able to read the MySQL data in sub-second real time. We're able to then send that to Snowpipe streaming, which would then load it into Snowflake, all within a few seconds in total with end-to-end latency. And at that point, Spot On could have carried on using the incremental models they were running, but they actually made use of dynamic tables instead. And it's another feature from Snowflake that helps make in this scenario, for example, the target table easier. You write a piece of SQL, and Snowflake takes care of the rest in terms of, okay, do I need to do a full refresh or incremental model, set it a target lag, and it updates. Today, dynamic tables work to a 1 minute lag, but they're about to release or out to, I think, early access 10 seconds also. And so, combined with swapping out Fivetran for a streaming product like us, coupled with Snowpipe streaming, led to a 5 second latency end to end, and then also coming on some of the benefits, it actually costs less. All downstream processes were improved and ran faster. And on top of that, by the way, they can actually now, because of the way streaming data often works, they can also look at a state of a record at any point in time historically also. And that was just fixing the MySQL to Snowflake pipeline. But on top of that, you can then expand onto other destinations as indeed Spot on have done. So you can easily go and do, for example, batch outputs to S3 and consume that data elsewhere. So you don't have to keep everything flowing real time. You could put that into another database, such as ClickHouse, for example, for a customer facing app, and so on. So the premise here is start with real time, use that downstream, but of course you can slow it down and use a kind of batch update in the right use cases also. And it's kind of like, well, why wouldn't you, if it's faster and cheaper and then benefits all the downstream processes? So so that was the result that Spot on got.
Great. Thanks, Ricky. And I think that's kind of indicative of what we're seeing is that that reality, as much as we position this as batch versus streaming, that I think it's less of a wholesale decision of one versus the other today, and more kind of an incremental adoption that we're seeing, right? And so as we talked about just now with Spot on, we were able to they were able to deploy StreamCap as a drop-in replacement for Fivetran. Super easy, very low lift. No major changes to really anything in their stack other than the ETL tool, and then leveraging native solutions within Snowflake to handle that streaming data, which they've done a great job of. And by the way, BigQuery and Databricks and other destinations, ClickHouse, all have released functionality to support streaming data. So it's increasingly becoming easier to get that data into your analytical stack. And so that's kind of like the common first step that we see for folks. And then we start to see some expansion out, as Ricky was just discussing, right? Going to other destinations. You might be sending to Snowflake for some use cases and to ClickHouse for others, or to S3. We also see folks, StreamCap is built on Kafka. And so the first stage is kind of treating it just like an ETL tool. But then we see folks saying, well, actually, can we leverage that underlying Kafka? So we have folks writing events to Kafka and reading from Kafka for other event-driven systems downstream. So there are a lot of cases where, like, I think you start with that simple view, and then you start to build out from that. And then another big chunk of area where we see folks building on on that initial entry point is transformations. So we have Flink under the hood to help power that. And we see a number of different things, applications for that, but everything from very simple masking PII data through to unnesting semi-structured data from data sources like MongoDB and DynamoDB. That's been a very, very common use case where you get to take advantage of a much more efficient approach to handling the compute associated with getting that data in the right structure to work well with Snowflake or ClickHouse. And again, that's another case where it's both lower latency and lower cost than the traditional approach to doing that. And then we're starting to see some more sophisticated transformations as well, doing joins of different data streams, the website event data with transactional data, to power real-time recommendations, as Ricky was talking about earlier as well. So yeah, it's been interesting to see folks move, again, rather than thinking about it purely as a binary thing, just say, like, actually, where can we now adopt streaming easily that's going to have all upside for us, and then explore from there. So yeah, if you're interested in learning more, you can reach out to me via email, paul@streamcap.com, or we have a free trial, so you can actually just sign up on the website, streamcap.com, and check it out. And then there's in-app chat there if you have any issues, or generally when folks are doing a trial, we'll set up a shared Slack channel. Yeah, feel free to get in touch with us on either of those methods. Now, I think let's turn over to folks for any questions that you have coming out of this, and we'll see what folks have to say. So let us know in the comments what questions you have. And actually, jump back to that last slide if you want to just note down the contact info. So, all right, we've got one question here. Might hand this over to you, Ricky. The cost side of things, you touched on this a little bit with the spot on stuff, but and we talked about it at a high level. But anything else you can kind of share on like how costs are kind of comparable to batch?
Yeah. So it's quite tricky because different batch tools, some are very expensive, some are cheaper. But let's take the spot on scenario where we think about Streamcap to Snowflake, for example. And we'll just talk about that in kind of ingestion pipeline. So looking at our looking at our literally our website, for example, it's 100 million. Yeah, and this is on an example price, but 100 million rows per month, which is typically how these batch ETL tools work. Is as little as $500 a month. So I think that's pretty low compared to batch ETL tools. And then if you look into the ingestion, as I mentioned, Snowpipe streaming is practically for free. It's just like $30, $45 at most per terabyte of data. So hundreds of millions of rows of data, absolutely no problem getting into Snowpipe streaming. The cost, therefore, where it can add up a bit more, is in the post ingestion transformations. What we see is when you look at the, this is still then the use of a Snowflake warehouse. I'm not sure I mentioned it earlier, but Snowpipe streaming doesn't use a warehouse, so that's why it's so cheap. Also, they've just made it really easy to get the data in. And then, that post processing, if you want to create extra transformations, final state tables, and so on, then you'll spend on a Snowflake warehouse there. This will still work out significantly cheaper than what you're currently spending in the Snowflake warehouse to do, usually these merged updates. But either way, if you compare the ETL tool, the cost of the ETL tool plus Snowflake costs to Streamcap plus Snowflake costs, then it should be usually about half the price. It does vary depending on how fast you want to run those post-loading transformations, but I think the very worst case, 3/4 of the cost, but usually a lot less than half, basically. And that scale improves as you get more volume. And other databases also make it easy to get streaming data in now as well, including the likes of ClickHouse and others, where you can just stream in billions of rows even with very little cost.
Yeah, I think we've seen the same or similar with BigQuery. It's maybe somewhat specific to Fivetran, but Fivetran their ingestion approach drives a lot of cost on BigQuery, and we use the streaming storage write API, excuse me, which is much lower cost on BigQuery as well. So similar kind of pattern there. We have another question here on whether Streamcap can connect to Microsoft Fabric via shortcuts. I don't know.
I'm not so familiar with shortcuts. Give me 30 seconds and I'll just check.
Yeah, so. I think we do support writing to Azure Blob Storage, and so I think we'd have to look at shortcuts specifically, but we do have support for for a number of destinations in in the Azure landscape, but we'd have to just double click on the shortcuts with Fabric.
Yeah, so I just if I read it right quickly, we do support Azure blob storages. So then it looks like you can then create a shortcut within those to point to them. So yes, we support ADLS. So I think that then allows you to support shortcuts. But yes, we support Fabric in effect through that.
Great. Well, we're at time here, so I think we'll kind of have to cut the questions a little bit short. But yeah, reach out to me via email if you've got questions. and we can, let's see, yeah, let us know if you want a copy of the recording as well. We'll send that out over email. And then folks joining on the LinkedIn, you can, if you want to share this with other folks, you can actually just share this LinkedIn event with folks, and they'll get the video. So yeah, thanks everybody for joining, and yeah, hopefully that was helpful to learn about streaming, and get in touch with us if you're interested in learning more about how StreamCap can help specifically.
Yeah, thanks a lot.
All right, thanks all.